Hello and welcome back, my fellow math contest enthusiasts. Root Beer here, going through the grade 7 Gauss paper from the year 2009, and we are up to question number 24. Second last question of the contest. It's still not too late to print out a copy and try it for yourself. Give yourself maybe 10 minutes, see what you can make of question number 24, and then come back and rejoin me for the video. So, in square, A, B, C, D. So it's a square. They don't have it, they do sort of have it on their diagram, but I'll also mark these sides. They're the same length. Okay. P is the midpoint of DC, and Q is the midpoint of AD. All right. If the area of quadrilateral QBCP is 15, what is the area of the square? Okay. How can we figure this out? Well, I'm being told the area of this weird sort of quadrilateral. Can I break it down into maybe some values that I might be a bit more comfortable with, or some shapes I might be a bit more comfortable with? Well, sure. I think if we connect B and P up, we'll get two triangles, and that might shed some light on the question a little bit. Another thing to notice is we're talking about a square. We want the area of this square. So if we knew, say, the area of its side length, so if we call the side length S, if I know what S is, S squared is the area I want. Okay? Well, there's an S, there's an S. And now P is the midway point. Got to finish labeling my picture, actually. P is the halfway point, Q is the halfway point, so these sides are going to be split in half, and they become S over 2. Okay. So, what can we do? Now, we've got a bunch of right angles here, because it's a square, and squares are technically rectangles. So I suppose we could say something like triangle BCP has area of 1/2 base, which is 1/2 S, times height, which is S, and this is going to be S squared over 4. And with the exact same sort of reasoning, I can figure out the triangle ABQ that has a base of S over 2 and a height of S, as long as we sort of rotate it in our mind. It's also going to have an area of S squared over 4. And this other triangle down here in the bottom, DPQ, or I'll say PDQ, try and keep the letters slightly alphabetical, with D, that right angle in the middle, is going to be 1/2 base of a half S times height of a half S. It's going to be S squared over 8. Now, what has this actually gotten me? Well, not entirely a whole lot. Because I can't assign any actual numbers. Everything here involves S. I gotta sort of face the facts that I need to talk about B, Q, and S. That's what I think I need to calculate. And, how should I do that? Oh, you know what? So this triangle in the middle here, if I knew that in terms of S, and since I know this other triangle in terms of S, add them up, I've got an equation for S that equals 15. So I should be able to solve for S. But maybe this isn't the only way to break it up. And I just thought, what if you... Because that triangle in the middle, it doesn't have any sort of flat sides. But what if instead I broke it down into... the triangle here and sort of a quadrilateral here. And so this triangle, if we called this point R, the midpoint over here, connect these up, you're going to get a right angle. Just cut straight across. S over 2, you'll get an S over 2 here. This side is S. And so actually, BSQ also has area S squared over 4 because it's got base of S over 2 and height of S. So that's good. And I could figure out QRCP is a trapezoid, and I do have its height and its two parallel sides, so I could do that, or I could also say, well, it's the big rectangle QRCD minus this small triangle here. Either way, I get the area of QRCP is fine. I'm going to use the trapezoid formula, but feel free to just subtract this right angle triangle. We already have its area in terms of S. That wouldn't be a problem. But since I saw it as a trapezoid first, I think I'm going to go with that. PCSQ, it's 1/2 the height, which is S over 2, times the sum of the parallel sides, which is S plus S over 2. So this is 1/2 S over 2. S plus S over 2 is 3S over 2. So we get 3/8 S squared. Okay. But, let's switch back to black. We know that 15 is, and this wasn't a triangle, 15 is QBCP, but that's the same as BSQ plus PCSQ. So that's S squared over 4 plus 3/8 S squared. This value and this value here. And 1/4 plus 3/8 is 5/8 S squared. So multiply both sides by 8 and divide both sides by 5. I get 24 is S squared. Now I could square root and find S, but remember, I just need to know what S squared is, because that's the area. So it looks like 24 is our answer. Now let's check, is 24 one of the possible answers? Yeah, there it is. It's E. And that finishes up our second last question. We've got one more to go. Question number 25. Do give it a try before watching the next video, but I will see you guys there as we take it up nonetheless.